Imagine this. It's August in Rajasthan. A farmer looks out at his field. What once was green and full of hope has now been completely diminished by locusts. Now, this is a case study that happened in Rajasthan and Maharashtra. Standing crops worth over 7,000 crores were due to unpredictable monsoon shifts and pest infestations have been completely destroyed. Right? So farmers face first one is finding out crop suitability, pest infestation, and at the same time so, farmers from on the most, as you know, Indian is an agrarian society. Our trade, culture, values, everything is built off of agriculture itself. Current crop planning is quite short term. It's not built on the longer term. Right? Major crop issues are based on trends and what people follow, but not on scientific basis. So that's where our solution comes in. What is our proposed solution? So we're trying to build an AI-powered digital twin for agriculture, which combines two different major problems. So one of the major problem is finding out crop suitability. So for each and every crop like rice, wheat, soybean, etc., which areas are particularly good for growing them. And the second thing is pest infestation. Now, as you know, in certain areas, as the chlorophyll diminishes very certainly at that in particular riverbeds, it causes the chlorophyll to diminish suddenly. So this subsequent diminution in chlorophyll is a result of pest infestation. As pests eat majorly all of these plants, it leads to degradation as well as destroying of each of these plants, and that can affect farmers on their livelihoods as well. So that is where our solution comes in. We integrate satellite GIS imagery from Sentinel to Copernicus imagery. And then we also use our own AI-based algorithms, which includes transformers, ResNet 50 model, and simple random forest model that can make the process much more efficient and computationally efficient. So what we're trying to do is we're trying to be future and present ready. We're trying to take into effect all the past trends as well as the future trends in order to determine which areas are particularly well suited, right? So we can provide these inputs in form of heat maps so that farmers can better understand them. I say the digital. So here we're majorly focusing two different types of stakeholders. First one is directly to the farmer. Second one is to policymakers so that they can make better informed decisions, as well as private institutions which require a lot of these technologies, like for example in space, IIRS, etc. As we know, the digital agriculture sector in India is projected to generate an estimated economic value of 65% billion dollars, which can be a testament to its growth as well. Now, let me get you to the prototype. So, the prototype of the dashboard looks something like this. Here, I select my particular region, in this case, Africa Jharkhand, and I click on search. Now, once I've found search, the model accurately cuts out that particular state. And then, let's begin with crop suitability. When I click on crop suitability, let's try to understand for rice how good is Jharkhand. So, for example, Jharkhand is a place where rice grows majorly. It's quite known for its green fields for rice. And on the other hand, it doesn't grow that soybean that well, and that can be reflected on our dashboard as well. So as you can see, on crop suitability, it stands very much on the mediocre slash less ranked as well as more risky to grow in these particular areas. It also provides us insights on which areas we can avoid to plant these particular crops. And then let's try to understand how we are going to determine pest infestation. As I already mentioned, the pest infestation determination can be happening using NDVI. The sudden drop in NDVI in particular areas, especially near riverbeds, can be an analysis for how much pest has infested in that particular area. Now let's try to our solution. What it does is we try to integrate both of these solutions, both the crop suitability as well as the pest infestation, so that the farmers can make a better informed decision on what to do. Not just the farmers, policymakers, and private institutions as well, already mentioned. Now, let's click on update analysis and wait for the update. It takes its own time to compute. In the meanwhile, I would also like to show you how our model makes it much easier for farmers to understand and the dashboard as well. This technical lingo cannot be understood directly by farmers. So as a result, we are going to provide them with a dashboard. Let's say I want to take rice here. Can click on update analysis and it will just let it compute. I'll take it here. So let's say here, if I ask any type of question, like for example, um, I am situated in Purulia. What are the um, what are the ways pests can infect my rice field? Okay, so let me hit answer. Yeah, so it gives direct insights. For example, what temperature to build, what type of requirement is needed with respect to water, and transplant at 3 to 4 leaf stage, and spacing of 20 to 20%. But this data can directly be understood by these farmers to analyze and help farmers make a better informed decisions on what to do exactly. So here you can see most of these areas are marked red or orange compared to the rest of the body. Now this can be confirmed as we have already seen in Jharkhand. There is quite a lot of coal mines in this particular area itself. So yeah, we can understand quite a lot about topography, climate data, and soil imagery by just looking at GIS analysis. And this can be a testament for all of these farmers. This is what we're trying to build. We're trying to revolutionize the whole agriculture market and digitalize the whole process so that science can help aid better, make better decisions to farmers as well as other people. Also, I would like to add on the integrated analysis, it also gives you percentage for how suitable it is to grow particular types of crops, right? So this is how our